Now, I would like to introduce Jeffrey Haas. I say that right, Jeffrey? Excellent. Presenting BGP Flowspec, a look back and a look forward. Jeffrey is a distinguished engineer at Juniper Networks, chair of the IETF IDR Inter-Domain Routing Working Group, as well as the chair of the BFD Bidirectional Forwarding Detection Working Groups. Jeffrey traveled to us from Michigan, and we're happy to have him here today. Once again, welcome, Jeffrey, and thank you for talking about BGP.
Thank you. Microphone? Thank you. So good afternoon. I know we're running a few minutes late, and never stand between NANOG folk and their break. So we try to keep this on time. So it's been a few years since I've actually been to a NANOG for purposes of giving a talk. I've been to a few of them, over the years, not anywhere near as much as I probably should. Last time I was here, I had a lot less gray in my beard. These days, I have a lot more gray in my beard because of the thing we're about to talk about today, which is Flowspec. Our little picture here shows the fact that we have a rear view mirror with explosions in the background, and this is just a thing that is true for Flowspec. Flowspec causes a lot of pain. Pulling a bit of wisdom off of the NANOG list, what is automation? It's breaking the network at scale. It's really hard to do truly evil things to your network without actually having a little bit of help. So just a reminder, what is BGP Flowspec? It's a feature that's there to distribute firewalls into BGP. I repeat that, firewalls into BGP. The most important use case for it is mitigating denial of service. It's incredibly helpful. We have a large number of people across the internet and various service providers of gigantic size to small, making successful use of it to actually mitigate denial of service issues. So it does get used. It was originally put forth in IETF as an RFC 5575, got updated a few years ago into a new RFC to try to clear up a lot of little small issues. There are people in this room that are responsible for having worked on Flowspec. Some of them say, I'm sorry. But the mix of people that were working on it was a nice collaboration of people that did work in IETF, vendors such as myself, and operators that actually had real problems to solve. So the problem is, whatever could go wrong. And we all know this because we actually get to see this stuff pop up in the news when it does go wrong. Because Flowspec is about distributing firewall rules. And firewall rules are sometimes the best place to solve specific types of attacks. It's also a good way to do really clever things. It lets you, especially if you have the ability to interact with features that are popular in Flowspec, like redirect to VRF, redirect to IP, let you actually take this traffic and send it somewhere else on your network to do something useful with it. You can look at the contents of it. You can scrub the traffic. You can mitigate attacks. People use this stuff successfully all the time. And that said, if you're just trying to actually stop simple volumetric attacks and you're willing to complete the attack itself, things like real-time black holes still are perfectly usable things. So the problem we really have is that firewall word is in there. Firewalls have a lot of features. You go to the different sets of vendors across the entirety of vendor space, depending on what they're doing. It could be as simple as Linux IP tables. It could be as complex as something as deep as our SRX stateful firewall inspection. Flowspec tries to actually do a lot of the common things that can be done, especially on routers that were originally deployed as ASBRs, stuff that is intended to be high-speed packet forwarding elements that get the traffic through as fast as possible. This means you can't do fancy things like stateful inspection. You can't do a number of things that require deep digging into a lot of the packets, although as you'll see, we're getting to the direction where that's a desire. So Flowspec is mostly limited to the set of features that is covered by the stuff that core routers can take care of. Now, the problem with firewalls, though, is that anybody that's operated any network with more than one kind of firewall in the network at all knows you can't get the full set of things to work exactly as you like. Some features are supported universally. Some of them, have various issues. As an example, even Juniper, which is a long-standing supporter of Flowspec, we had some issues with DSCP in some of our implementations back in the day, and this caused some people problems when they were trying to have specific mixes of rules. So the challenge that you end up having as an operator is, what can the firewall actually support? Are all the operations supported? What happens if you're missing one of the core primitives that you're trying to use for mitigation? And what happens if you have strange limitations on them? Maybe Flowspec allows for arbitrarily long port lists, but if you're restricted by the number of matches you can do. And what about the scale? So maybe you do perfectly fine for a couple dozen rules. Maybe you do fine for thousands of rules. Maybe there's a lot of that depends in there. And of course, what about bugs? Bugs make people crazy because just because you think something's supported, when you need it most, sometimes it doesn't help you. So again, Flowspec is about distributing firewalls into BGP. What could go wrong there? Flowspec is a way of serializing an actual firewall tuple into a BGP route, an LRI. And it allows you to couple these things with a set of actions with your match criteria. Those usually go into an extended community. In BGP, it's one of the very few things that we have that serialize arbitrary content, and it's not strongly structured. BGP link state is one of the few other things that does that sort of thing. So the challenge is, it's a complicated format, but it lets service providers rapidly deploy firewall rules across your network. And especially if you're using a deployment that's leveraging route reflectors to do this, it can make your job very easy. Flowspec lets you actually accept Flowspec routes from your customers. One of the last times I was standing at a microphone at a NANOG, I said, "Are you crazy? Why would you want to do this?" It's a feature that some people like. It does have some security mechanisms there. It does have validation, but it does mean that anything that is problematic in Flowspec itself, you're now taking on that potential damage from your customers as well. Serialization is challenging. You look at any number of mechanisms for doing this sort of thing, you'll find different ways to do it. Flowspec doesn't have universal canonicalization for things. If you're putting in a list of things, there's not always a single way to do it. This makes interop a little bit challenging. And the biggest headache that we have is that Flowspec isn't a traditional type length value protocol. For strange reasons, which maybe somebody will shed a little bit of light on after the talk is done, the length field didn't actually make it in there. And as a consequence, we missed an opportunity to allow the protocol to be arbitrarily expended. So as part of the work that we did in revving the RFC that Flowspec lives in, we said, well, it was intended to be this opaque thing. That didn't work out so well. So we're sort of stuck, and we now have a Flowspec v1. This has harmed incremental deployment, and pretty much core Flowspec has been frozen since then. And the thing that drives everybody crazy when they're dealing with Flowspec, half the things that make the news, is that the sheer flexibility that Flowspec has means that all these things can go wrong, and they can potentially take your BGP implementation with it. It drives people crazy. It makes people afraid of Flowspec. And if you get a session reset, and you're not separating things, well, that takes everything along for the ride. Strong recommendation that we have these days is that Flowspec's deployed as a separate session. So this is a firewall. The problem with firewalls is firewalls are all about rule ordering. So what do you do about that when these things are coming in your network as a completely arbitrary set of things, potentially from many routing sources? So Flowspec, as part of the RFC, decided to do a canonical rule order. Order is important for firewalls. You have to make a choice. The choice is basically there to allow for firewall ruling against DDoS. And that order actually works out okay. Destination's the first thing you match on. You basically work your way down the list based on the different component types. They're ordered by the things that largely make sense. And then past that, longer it is, the more specific it is. you'll filter that to the top, and generally it will do the right thing. But sometimes you can't get a firewall behavior for a type of attack traffic that you really want to. Flowspec ordering just doesn't let you handle that. And it's great for simple DDoS, but it's not great if you want to do anything sophisticated. So for some cases right now, you're just stuck. And the problem you have is that the flexibility that you're desiring, being able to order things somewhat arbitrarily. If you're in a real firewall, you move things around. In the protocol, you don't get to do that. And of course, you add bugs as another consideration. One of my colleagues, Dr. Tony P., has a very bit of useful wisdom about BGP. It's a Swiss Army knife. It has no handle. It's just all knives. It's a very sharp tool. You will cut yourself at some point if you are an operator. Every one of you in this room that has some sort of access to a router will have that oops moment, which if you haven't lost your job from it, you'll definitely have that pale look on your face as all the blood's drained out. Is my network actually still working? Sometimes the best tool for the job will cut you. So despite the fact that Flowspec is a sharp and dangerous tool, it has helped so many customers. And this is why we keep seeing it used. It's why we keep on seeing it pushed for more features, to extend things, despite the fact that it's got so many problems. Large scale providers use it every day to protect their customers. It's largely vendor neutral with the problems we were talking about. And as much as people talk about why are we dumping all this stuff inside of BGP, one of my other colleagues likes to say, the protocol is not a dump truck. Well, as much as that colleague likes to say such things, and he'll speak for himself at some point later, I suspect, you have to get the stuff around your network sometimes, and sometimes in-band has strong advantages to it. And even if it was out of band, you still have to figure out what other channel could it go into. Do you put it into netconf? Do you put it in gRPC? You're going to still have a lot of the same headaches we're talking about. Just because you have a different mechanism doesn't mean the headaches necessarily go away. And being able to couple this stuff with your routing, especially when use cases such as matching stuff against customer routes, if you're doing customer BGP for Flowspec, or if you're doing redirection and you want the redirection to use tunneling to mitigate the traffic via off-ramping, having a coupled routing protocol can do the job. So the question is, what can we do to help things do better? So we start getting into a little bit of the future. Flowspec v1, as I mentioned, was sort of stuck. It was partially misdesigned. We have to have a way to actually allow things to move forward. Within IETF, the IDR working group that I'm co-chair of does have work going on for Flowspec v2. The goal of that is to try to actually fix some of the issues that we found. Some of them are very simple. Number one, make the thing an explicit type length value field to make sure that we can incrementally deploy new features without problem. This gets rid of the issue of session resets. It allows features to be added incrementally. Second thing, and an incredibly important one, is allow that explicit rule ordering. Cases where the operator needs to bypass the usual rules for Flowspec for some specific reason. Sometimes it's just as simple as having a firewall implement things as an order that you're expecting. Sometimes it's because an implementation has limitations that reordering can make things better. It also allows us potentially long-term to do, in the Flowspec v2, smarter action clustering. Right now, if you have features such as redirect IP, redirect to VRF, and we have additional things like redirect to path ID, we're starting to see these things as additional rule chains have interactions with each other. Having the protocol be clear about how they work together is important. A big problem that we have IETF-wide and you as operators are having to deal with, especially as you move to controller-based networks, is how do you deal with scoping things? Making sure that your features that are working around your network can actually be successfully deployed in the places that do understand them and places where, if it's harmful, can you avoid deploying them there, or potentially just simply allow your controllers to figure out if there's support for this thing over here, do something smart in the place that has the brains for it. Everything else, maybe I do something slightly dumber that still helps. So work shall actually be happening inside the IETF to help with this, across IDR and a few other places. And part of this is also going to be limitation features to allow things like Flowspec to only go as far as it actually needs to go. So as I mentioned, being able to figure out what your devices can do. Capability discovery is a thing that is becoming a general topic. It's not centrally distributed around IETF. We have examples of if you're running MPLS as a network and you're doing label imposition, having features to do maximum segment depth as an example that live in the IGP can help things actually do appropriate MPLS imposition smarter. You don't try to overflow your label stack accidentally in your deployment. The question is where you start putting these features. Do they show up inside the IGP? Do they show up outside the IGP? There's a tension both directions. Running low on time. My last slide. Things that are happening in IETF with Flowspec v2. Again, the whole point is to allow the door to open for new features again. We have flexible payload matching to be able to do matching on payload contents. We have a desire for doing matching on things that are layer 2 related, sometimes layer 2 VPNs. Matching on the contents of tunnel traffic, which if you're doing fancy encapsulations as part of your network designs, especially if you're doing tunneling across UDP or GRE or other things, doing those things breaks your ability to do stateful firewall or non-stateful firewall. That's a problem for you. These extensions potentially can help. And we're seeing not only for more interesting science, experiment type mechanisms that may turn into more general mechanisms, we're also seeing things like segment routing as a technology starting to get more coverage as well in Flowspec. So what is my request to you? As operators, please pay attention to the work in IETF, whether directly or through your vendors. Let us know what you're actually looking to implement. Let us know what your actual problems are in your network. And hopefully we can see that Flowspec serves not only as a tool that makes people unhappy with what goes wrong, but actually helps us build things that actually help things go right. That's it. Thank you.